Bariha Farooq to please come on stage for the recitation of Holy Quran.
أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم طه ما أنزلنا عليك القرآن لتشقى إلا تذكرة لمن يخشى تنزيلا ممن خلق الأرض والسماوات العلى الرحمن على العرش استوى له ما في السماوات وما في الأرض وما بينهما وما تحت الثرى وإن تجهر بالقول فإنه يعلم السر وأخفى الله لا إله إلا هو له الأسماء الحسنى وهل أتاك حديث موسى إذ رأى نارا فقال لأهلهم قثوا إني آنست نارا لعلي آتيكم منها بقبس أو أجد على النار هدى فلما أتاها نودي يا موسى إني أنا ربك فاخلع عليك إنك بالواد المقدس طوى صدق الله العظيم.
Jazakallah. To kick off our Devfest journey, we have the honor of welcoming a passionate advocate of technology, an exceptional speaker. Please join me in welcoming the one and only Iram Zahra, a proficient data scientist with 6+ years of experience, excels in predictive analysis, natural language processing, and machine learning pipeline management.
Okay, so hello, आप सबको मेरा पता होगा. I am manager GDG Cloud Islamabad, and I'm also working as a senior consultant data science at Systems Limited. उसके अलावा I'm a founder of Islamabad AI and an ambassador of Women Tech Makers. So GDGs are basically Google developer groups. They operate globally. हर major शहर में, मुल्क में, there are multiple GDGs. ठीक है? Same goes for WTM. WTM is Women Tech Makers. It's an initiative by Google and it comes under Google developers. So basically GDGs का purpose क्या होता है? जैसे आप सारे आज यहाँ बैठे हैं. So basically what Google developer groups do is that they gather developers like you and we enable you to be connected with like-minded people, जो basically students, to connect students with industry professionals basically. और जो WTM है, WTM comes under GDG. It's same. WTM is basically just not women tech makers. हमारा जो focus है, it's wider and it basically represent all the underrepresented groups, जिसके अंदर सारे underrepresented genders, races, including women, सब आते हैं. ठीक है? And अभी आप लोगों ने Women Tech Makers ब्रेकफास्ट अटेंड किया था. इस ब्रेकफास्ट को WTM ब्रेकफास्ट का मकसद ये होता है, ठीक है, we basically enable women in tech to network with each other. मेरा बहुत strong belief है इस चीज़ पे that we have a very few role models in tech industry जो कि women हैं. And what I try my best is to link those women जो टेक इंडस्ट्री में बहुत अच्छा काम कर रही हैं विद स्टूडेंट्स एंड विद एनी वुमेन जो उनको एज अ रोल मॉडल परसीव करके दे कैन एक्चुअली फॉलो देयर पाथ में भी, ठीक है, गाइडेंस ले सकते हैं। नेटवर्क आपके पास, आई स्ट्रांगली बिलीव ऑन योर नेटवर्क। जो आप यहाँ पे लोग आए हो अपना नेटवर्क जो बिल्ड करके जाते हो, मुझे ऑनेस्टली बहुत फ़ायदा हुआ है हमेशा अपने नेटवर्क से, एंड आई बिलीव कि अगर आप चाहो तो आपको भी हो सकता है। सो दैट इज़ वाई इट्स द पर्पज़ ऑफ WTM नेटवर्किंग ब्रेकफास्ट, ठीक है। रेस्ट ऑफ यू कैन स्टिल network here during lunchtime after the breakfast, and you can connect with each other over the LinkedIn, right? अच्छा, women tech makers और GDGs हो गए हैं, हम नेक्स्ट स्लाइड पे जा सकते हैं। हाउ मेनी ऑफ यू हैव अटेंडेड डेफ फेस्ट इससे पहले? बाकी किसी ने कभी डेफ फेस्ट अटेंड नहीं किया? और GDG क्लाउड का कभी कोई इवेंट अटेंड किया इससे पहले? और बाकी सारे नए लोग हैं। हाउ मेनी ऑफ यू आर बैरियंस? ज़रा ज़ोर से बोलो, पता चले बैरिया में आए हैं हम। अच्छा, ये बोलना क्यों शुरू कर देते हो, मुझे भी बताओ। आपस में भी बातें करनी शुरू करती है, मेरी बातें सुनो ना यार। सो दिस इज़ द मोस्ट इम्पॉर्टेंट स्लाइड मेरी सारी बातों में। GDG क्लाउड इस्लामाबाद क्या है? देयर आर GDGs एंड देयर आर GDG क्लाउड चैप्टर्स। So I would like to take this opportunity to explain GDG और GDG Cloud में क्या फ़र्क होता है, because I think 90% of you don't understand what is the difference between these two chapters. So basically, GDG chapter is we are all official communities of Google. We have same goals at the end goals, but we are differentiated by technologies. We being GDG Cloud, our focus is on cloud technology, basically any technology that comes under Google Cloud Platform, which includes artificial intelligence, आपकी data science, machine learning, deep learning, anything like that, including everything that goes on cloud. GDG Cloud का focus है, as the name suggests, cloud technologies, और जितनी भी आपकी AI से related technology हैं, it comes under Google Cloud. So, we basically represent all AI, big data, data science, machine learning, deep learning, आपका पूरा GCP platform. अब GCP platform के there are hundreds of things. This is my favorite slide as well because it has a snapshot since 2019. हमने cloud chapter 2019 में start किया था. So हम लोग अभी तक इस event के अलावा हम 45 plus events कर चुके हैं. 45 events, the big conferences like IWD, Devfest and IO. एंड क्लाउड नेक्स्ट 35 प्लस टेक्निकल वर्कशॉप्स थी जिसके अंदर से ज़्यादा ही होती हैं हमारे पास। आप लोग हमारा community.dev वाला लैंडिंग पेज विजिट कर सकते हो जहाँ पे हमारे सारे पास्ट इवेंट्स डिस्प्ले पे होते हैं। हम लोग नॉन टेक्निकल वर्कशॉप्स भी करते हैं। मैंने अभी तक सबको टेक्निकल बताया, बट वाई डू वी डू नॉन टेक्निकल? बिकॉज अगेन सॉफ्ट स्किल्स, नॉन टेक्निकल स्किल्स आर वेरी इंपॉर्टेंट फॉर डेवलपर्स, जो मुझे ऐसा लगता है कि बहुत कम होती हैं। दे आर वेरी गुड डेवलपर्स बट दे लैक, इंक्लूडिंग मी। बहुत अरसे के बाद मेहनत करने के बाद कुछ बेहतर हुई है हमारी सॉफ्ट स्किल्स। और कुछ इवेंट्स हम कोलैबोरेशन में करते हैं। बाय कोलैबोरेशन आई मीन हमें कोई और कंपनी या कोई और यूनिवर्सिटी इन्वाइट करती है टू डू समथिंग फॉर देम, सो हम ऑर्गेनाइज़र बन जाते हैं और होस्ट वो यूनिवर्सिटी होती है। उसके अलावा अगर मैं अटेंडीज़ की बात करूं तो 10,000 से ज़्यादा अटेंडीज़ को हम होस्ट कर चुके हैं, एंड दीज आर 10,000 यूनिक अटेंडीज़। हमारे पास रेपिटेटिव अटेंडीज़ भी आते हैं। सो दीज आर द स्टार्ट्स फॉर GDG क्लाउड। अगर मैं WTM की बात करूं तो WTM के 30 प्लस इवेंट्स हैं जो हमने वुमेंस के लिए किए हैं, जिसके अंदर क्लाउड की ट्रेनिंग्स, मशीन लर्निंग की वर्कशॉप जो हमने सिर्फ लड़कियों के लिए की थी। इस तरह के इवेंट्स उसके अंदर आते हैं, जिसके अंदर वर्कशॉप्स मतलब जहाँ पे हैंड्स ऑन आपको कुछ सिखाया जाता है, जिसके अंदर नॉन टेक्निकल चीज़ें भी होती हैं जैसे कि पिचिंग, नेगोशिएशन स्किल, सेल्फ ब्रांडिंग, पब्लिक स्पीकिंग एंड स्टफ लाइक दैट। और मज़े की बात यह है कि अगर कोई इवेंट WTM इवेंट है, दैट डज़ नॉट मीन कि मर्द हज़रात उससे अटेंड नहीं कर सकते। वी वेलकम एवरीबडी, बट बाय टैगिंग WTM इट मीन्स दैट वी एनकरेज कि हमारे पास ज़्यादा ख़वातीन आएँ। इसका ये बिल्कुल मतलब नहीं है कि जो मर्द हज़रात हैं वो अटेंड नहीं कर सकते, दे डेफिनेटली कैन अटेंड। ओके सो दीज आर सम लिटिल क्यूट पिक्चर्स जो हमने बहुत सारी पिक्चर्स में से कुछ थोड़ी थोड़ी सिलेक्ट करके रखी हैं, कुछ हमारी समिट्स की हैं, कुछ आयो की हैं. दिस वन इज़ आर नेगोशिएशन स्किल पिचिंग वर्कशॉप. और ये बेसिकली हमारा सबसे पहला इवेंट है जो कि हमने कनेक्ट हब में किया था. दैट वाज आवर फर्स्ट वन. सो आप लोगों की पिक्चर भी हम किस दिन स्लाइड पर लगाएंगे. अच्छे अच्छे बन के बैठो. और ये हमारे पास पार्टनर्स हैं जिसमें से कुछ हमारे करंट पार्टनर्स भी हैं अभी भी. एंड आई थिंक हम जो भी चीज़ आपको डिलीवर करते हैं, जो भी इवेंट्स डिलीवर करते हैं, आप जितना भी सीख के जाते हो, जितना एंजॉय करते हो, इट्स बेसिकली बिकॉज ऑफ देम. सो बेसिकली व्हाट इज़ डेफेस्ट? डेफेस्ट इज़ योर एनुअल डेवलपर कॉन्फ्रेंस जो कि थ्रू आउट वर्ल्ड वाइड होती है. एंड दिस डेफेस्ट इज़ बेसिकली एक्सटेंशन ऑफ द डेवलपर कॉन्फ्रेंस हैपन इन अमेरिका. इसी तरह इसकी एक्सटेंशंस जो होती हैं वो पूरे साउथ ईस्ट एशिया में, यूरोप में, यूएस में, सब जगह एक्सटेंशंस होती हैं डेफेस्ट की. एंड दिस डेफेस्ट इज़ वन ऑफ दोज एक्सटेंशंस. एंड यू ऑल नो दैट द थीम ऑफ दिस डेफेस्ट इज़ AI. Hence the agenda related to AI. Everything you will see.
Professor Dr. Faisal Bashir to please come on stage to express his views about the DevFest. Sir, please.
Executive members of the Google Developer Group Islamabad, the esteemed Red Buffer management, worthy guests, speakers, respected faculty members, and dear students, Assalamu alaikum. On behalf of Bahria University, Islamabad, I extend a very warm welcome to all the participants in today's DevFest event. I am privileged to stand before you as the representative of Bahria University. We are grateful to all the industry experts who have spared time out of their busy schedule, especially it's a weekend, to participate and to motivate these young minds. I'm very happy to see a large number of students, faculty coming from different universities, not only from Rawalpindi and Islamabad, but from far regions as well. I'll take this opportunity to briefly introduce Bahria University to all the participants. So I'll be short. I'll not be going into technical details because I know that day in, day out you have been receiving lectures from professors and teachers. So today be the day for tech gurus. Ladies and gentlemen, Bahria University is a federally chartered public sector university of Pakistan. Established in year 2000, it has campuses in Islamabad, Karachi, and Lahore. Since 2000, we have seen a very steady growth in the university, and alhamdulillah, today we are one of the leading institutions of higher education in Pakistan. Bahria is a comprehensive university having a multidisciplinary portfolio, offering different programs under different faculties, including Faculty of Engineering Sciences, Faculty of Management Sciences, Faculty of Health Sciences, Faculty of Law, Social Sciences, and Faculty of Maritime Studies. With 20,000 students, 1,600 faculty, and around 90 degree programs at the offering, Bahria is a very vibrant community. And we are envisioned to become a knowledge and creativity-driven international university that contributes toward the development and welfare of the society. Ladies and gentlemen, the Faculty of Engineering Sciences at Bahria University, Islamabad, fosters academic excellence and empowers future computing and engineering students with comprehensive knowledge, hands-on skills, ethical values, and above all, the ways and means for lifelong learning. The Faculty of Engineering Sciences offers bachelor's, master's, and PhD programs in the domains of computing, electrical engineering, computer engineering, software engineering, robotics and intelligent systems, GIS and remote sensing, and environmental sciences. The Department of Computer Science in the Faculty of Engineering Sciences, which is co-organizing this event along with the Devfest team, is one of the oldest departments of Bahria University and has been operational since the inception in year 2000. The department hosts only in Islamabad 2,000 students and a 75 very well-trained and qualified faculty. The department offers programs at bachelor levels in computer science, artificial intelligence, and information technology. And at the master's level, we have data science, computer science, information security, and mathematics. Whereas we have PhD programs in computer science and in mathematics. Apart from the regular classroom environments and the well-equipped labs, we, in the recent years, recent 3 to 4 years, have established two prominent R&D facilities. One is referred or named as Center of Excellence in Artificial Intelligence, and the other one is the Cyber Reconnaissance and Combat Lab. And I'm very pleased to share with you, within just 3 to 4 years, only the CRC lab within the university has been able to secure more than 130 million rupees of external funded research projects from various government and non-government organizations. These centers provide not only an opportunity for the faculty to groom their research, but they are basically play a vital role in delivering hands-on skills to the students, and especially the master students in doing productive research. Ladies and gentlemen, being the Dean of Faculty of Engineering Sciences, I consider myself incredibly privileged to be part of a culture that prioritizes student success, upholds a dedication to exceptional performance, and values collaboration and teamwork. We at Bahria University value the need for a strong connection between academia and industry. Events like Devfest exemplify our commitment. These events not only provide learning opportunity to students, but also open pathways for professional development of faculty and research. I'm sure today's GDG event, Devfest, will provide young developers and the young ones from various universities to learn face-to-face from industrial experts, establish contacts, and to understand the latest trends and advancements in the tech world. Before I conclude, I would like to thank the executive management of Google Developer Group Islamabad for organizing this event at Bahria University. Here, I would like to appreciate the efforts of the Department of Computer Science, which has coordinated with the GDG platform and especially with the Google Developer Student Clubs to provide us with this magnificent learning and networking opportunity. I wish you all a day full of learning, networking, inspiration, and above all, a day full of happiness. Thank you.
Our next session promises to delve into the fascinating world of red buffer and artificial intelligence portfolios. Our speaker is not just an expert in the field, but also someone who brings a unique perspective in the table. Ladies and gentlemen, give a big round of applause for Noyan Shahid, Head of AI Red Buffer.
So I'm hoping कि जो अभी तक आप लोगों का दिन चल रहा है काफ़ी अच्छा स्टार्ट हुआ होगा, and let's continue कि हम इसको इस तरह ही लेके चलें. So without any further ado, let's start on the topic that I'll be discussing. So the main topic here that I will be talking about is creating business value from AI. And I'll start with the introduction. So my name is Noyan, and I am currently working as a head of AI at Red Buffer. My expertise are in building large-scale machine learning pipelines using computer vision, machine learning, and biomedical imaging. In parallel to that, I am also pursuing my PhD that's focused in biomedical imaging. And in the recent years, I've been working with government agencies, startups, and large enterprises by building their AI-based systems. So I'll take a couple of minutes to discuss the vision, expertise, and the portfolio of Red Buffer. So the domain expertise, the areas that Red Buffer generally works is around computer vision, generative AI, building recommendation systems, and NLP. Apart from that, everything that's under the umbrella of AI. The industries that we have been focusing on in the past couple of years are IoT and manufacturing, healthcare, fintech, energy sector, cloud infrastructure, and legal tech. And so let's move towards this session. So this session is going to be entirely around AI, and we will be covering how you can build AI products or how you could basically incorporate AI into your existing workflows. And I'll be backing those statements with a couple of use cases that would be relevant to industry-specific use cases and actual the problems that are occurring. What this talk would not be about would be discussing the engineering aspect of AI, and I would encourage people to be interactive, maybe ask a question after the end of this talk so that they could just seek clarification on AI or any questions they have around AI. All right. So before I present you with the use cases, तो दो चीज़ें जिसमें मैं compare करूँगा AI and that would be a human being. And the three main rubrics जिसमें comparison होगा would be the speed, second the accuracy, and the third one is scalability. On the basis of these three parameters, we would be evaluating कि कौन से ऐसे use cases हैं where you should be using AI-based system, whereas कौन से ऐसे use cases हैं जहाँ पर आपको AI use नहीं करनी चाहिए because AI is not always the solution for a problem. So we will be discussing those use cases like in detail. So the first use case जो कि आपको काफ़ी familiar होगा is market prediction. So just to give you an example, होता ये है कि like जहाँ भी publicly listed companies होती हैं, mainly in US या किसी भी country में, तो उनकी stock prices होती हैं, उनके market shares होते हैं, and investors generally जो कि invest करते हैं in companies में, they would want to look for a window जहाँ पर वो उसमें invest कर सकते हैं, maybe to buy shares at a very low cost and eventually उन्हें पता है company की एक potential है and the shares are going to go up. So currently it involves a lot of data to predict that price in real time. क्योंकि उसमें काफ़ी graphs real time पे data update हो रहा था and there are a lot of different data sources जिसकी basis पे you could decide कि stock की price क्या होगी. So there can be two ways to do that. Obviously, you can use an automated system to make those predictions for you. The first and simple way would be to ask a human being to give their own perspective around it. So moving to our framework, so we compare AI की क्या performance होती है on this certain task and the performance of a human on this certain task. So in terms of speed, we know that in order to get or predict the price of a share, काफ़ी ज़्यादा data involved होता है. और for a human being that's not experienced या किसी ने अगर stock market की understanding नहीं है, तो they might be able to make a prediction, but it would not be accurate and it would take a lot of time for them to give you an answer कि stock price क्या होगी. Whereas for an AI system or a general system, they could make predictions very fast. The reason for that is that computers are very good at processing data in a simultaneous manner. Second, the most important thing for this is the accuracy. कि कितना accurate होता है. So consider a human being that doesn't have much idea of how stock market works. तो उसमें ये कि they might be very inaccurate as compared to an AI system that was trained on a lot of data, जिसको a lot of information है, real time पे data मिल रहा है और वो predict कर सकता है. The last rubric is scalability. So for example, I ask a human being कि यार आपने पहले एक company को predict करना था उसकी stock prices. Eventually you have to scale up to 5 companies. और आपसे पूछेंगे एक ही time पे मुझे within a second या हर second पे मुझे आपने ये बताना है कि क्या stock prices होगी. So it would be very hard and very challenging for a human being to process that information in real time. But for an AI system or a typical computer program, scalability is not a problem because eventually अगर आपको 5 companies या 10 companies के लिए scale करना है, so you would be basically scaling up number of instances या आप compute बढ़ा देंगे and it would be able to solve the problem without any hiccups. So how the business value is created in this use case? So आपको ये पता है कि आपका data काफ़ी ज़्यादा है and a human can never beat a computer in terms of processing large amounts of data. तो आप ये करेंगे, you should be training or gaining insights from a human being जो कि expert है certain domain में. You train that model and delegate that task to an AI machine and do that certain, or ask them to do that certain task for you. इससे होगा ये कि you involve a human being in that certain process, train the model, and eventually get the desired results without deploying or using a high-level experts that could be costly and also time-consuming. The second use case that I'll be talking about is one of our recent projects जो हमने Red Buffer में complete किया was around solar feasibility. So consider कि आपके से use case है, let me, so this is, consider कि ये जो image on the left is satellite imagery जो कि एक image crop हुआ है from satellite, और ये एक rooftop है किसी घर की. तो the goal is कि we would want an AI system or any system that would be able to identify कि rooftop का कितना area है in terms of meters, और उसके बाद ये कि उस रूफ पे कितने सोलर पैनल्स इंस्टॉल हो सकते हैं. इवेंचुअली यू कुड कैलकुलेट कि एक सोलर घर के ऊपर कितने सोलर पैनल लगेंगे, उसकी इलेक्ट्रिसिटी जनरेशन कॉस्ट क्या है या कितनी कैपेबिलिटी है, एंड देन यू कंपेयर इट विद अ ह्यूमन. सो अगर इन टर्म्स ऑफ स्पीड की बात की जाए, सो अगर आप एक इमेज की टाइल को देखें तो एक ह्यूमन उतनी ही देर में बताएगा कि कितने घर हैं उस पर एज़ कम्पेयर टू जितना टाइम AI मॉडल लेगा. Secondly, in terms of accuracy, a human being would be more accurate in this certain use case because उसमें edges और boundaries ऐसी होती हैं और at times इतनी visible नहीं होती कि human being ज़्यादा अच्छी तरह identify कर सकता है in comparison to an AI system. The last point is scalability. So for example, अगर मैं आपको कहूँ कि given a zip code आपने सारे घरों को identify करना है, सारी rooftops निकालनी है, तो you might be able to do that, but that would be a very redundant and hectic task. So humans are not scalable in doing this sort of task, whereas for an AI system or a typical system, scanning images for a whole country or for a whole zip code is not a problem. So in terms of this certain use case, the key idea is here is that if an AI system makes mistake, that's not a problem, but because you would be able to scale it to a whole city. Moving to the business value for it. So for example, the business value for it कि यहाँ पर अगर कोई solar based company है, solar लगाने वाली company है, तो they would be able to know without actually conducting the survey कि एक शहर में कितने घर हैं और कितने ऐसे घर हैं जिन पे solar panels लग सकते हैं. So उन्हें जो marketing campaigns होती हैं, जो एक surveys conduct करने होते हैं कि कौन से potential customers हो सकते हैं, वो उनकी एक overhead ख़त्म हो जाएगा, and they would be just reaching out to those customers जो कि जिनके घर में पोटेंशियल एरिया है जहाँ पर सोलर लग सकते हैं. दे कुड बेसिकली स्टार्ट मार्केटिंग कैंपेन ऑन दैट सर्टन एरिया. इन टर्म्स ऑफ जो एरिया कवर करता है, लाइक सिंस AI इज़ लेस एक्यूरेट इन दिस यूज केस, बट फॉर एग्जांपल एक शहर है उसमें 100 घर हैं, एंड अगर AI जो है 70% ऑफ द हाउसेज को भी डिटेक्ट कर लेता है, तो उसमें कि यू हैव ऑलरेडी कवर्ड 70% ऑफ दैट सर्टन सिटी, और आप उस 70% ऑफ एरिया के साथ मार्केटिंग कर सकते हैं. वेयर एज अगर ह्यूमन ने काम करना, तो पहले ही क्यों, आपने पूरे शहर को का सर्वे करना है. सर्वे करने के बाद यू वुड स्टार्ट कोल्ड कॉलिंग दोज कस्टमर्स कि आप सोलर लगा सकते हैं. सो एसेंशियली इसमें 2-fold प्रॉब्लम को उसने 1-fold बना दी है, एंड यू कैन एक्चुअली जंप इन टू योर कस्टमर्स इन नो टाइम. तो दैट वुड बी अ यूज केस जिसमें आप AI यूज़ कर सकते हैं, एंड इवन इफ इट मेक्स मिस्टेक्स देयर वुड बी नो कंसिक्वेंसेज अराउंड इट. द थर्ड यूज केस इज कॉन्ट्रैक्ट एनालिसिस. सो फॉर एग्जाम्पल लीगल फर्म्स में होता है कि यू गेट लॉट ऑफ कॉन्ट्रैक्ट्स के वो काफ़ी लंबे लंबे डॉक्यूमेंट्स होते हैं, उसमें काफ़ी ज़्यादा टर्म्स एंड कंडीशंस होते हैं, एंड इट टेक्स लेट्स कंसिडर कि एक डॉक्यूमेंट है उसको 20 मिनट लगते हैं एक ह्यूमन को पढ़ने में, वेयर एज फॉर एन AI सिस्टम 1 या 2 मिनट में इट कैन प्रोसेस दैट डॉक्यूमेंट. सो लेट्स कंपेयर. सो दिस इज सॉर्ट ऑफ एन एग्जाम्पल कि एक ही डॉक्यूमेंट उसमें से कीवर्ड्स निकाल लिए कि व्हाट ऑर्गेनाइजेशन, किस ऑर्गेनाइजेशन के लिए डॉक्यूमेंट बन रहा था, किस डेट को बना था, मे बी एड्रेसेस क्या थे, क्या की कंडीशंस थी उसमें. उसके बाद सो लेट्स कंपेयर के दोनों की अगर कंपैरिजन बिटवीन AI एंड जो है आपका ह्यूमंस का, सो यू कैन सी कि एक्यूरेसी ऑफ ह्यूमन इज़ मोर एज कम्पेयर टू AI, एंड द पोटेंशियल इशू है इसके यहाँ पर अगर कॉस्ट, अगर आप कोई मिस्टेक करता है AI मॉडल, तो इट कुड बी वेरी कॉस्टली फॉर यू. सो ऑलवेज मेक श्योर कि यू अंडरस्टैंड कि व्हाट्स द कॉस्ट ऑफ योर मिस्टेक. अगर AI सिस्टम एक मिस्टेक करता है तो उसकी क्या कॉस्ट है, अगर एक ह्यूमन मिस्टेक करता है तो उसकी क्या कॉस्ट है. So just to summarize कि अगर आपने यहाँ पर इस certain case में like there are different use cases and you have to ensure कि किस तरह के use case में क्या आपने चीज़ use करनी है. For example, इस certain use case में when you know AI system can make mistakes, तो आप उसमें ह्यूमन इन द लूप को ऐड करते हैं सो दैट यू कैन डबल चेक कि आपने एक प्रोसेस कर ली एंड जस्ट स्किम थ्रू द आउटपुट क्या है ये, और वाज इट एक्यूरेट, वाज इट नॉट. सो इस तरह यू कैन मेक अ सिस्टम that's accurate with human in the loop, and you could reduce the workload of a human. And the business value that's been created कि आप काफ़ी जो timely काम था या task था, you can reduce the time of it to reduce it to exponential manner. So the key takeaway for this is, remember the cost of the mistake in this process is very, very high. So ensure आप ये करें कि whenever you are trying to build a system, AI system, see के उसमें cost of mistake की क्या वो है, cost of mistake क्या है. And with that, just in one slide, I would summarize के, so whenever you are trying to build an AI system, evaluate it against certain parameters जो कि आपके लिए important है. For me, speed, accuracy and scalability is important. The last two is कि अगर machine एक काम अच्छा कर लेती है, just delegate it to that. अगर कोई ऐसे task है जिसमें human और machine combine कर सकती हैं, तो just add human into the loop. And the last one is कि अगर एक काम human अच्छा करता है, don't get into it and let researchers come up with a solution that's more accurate.
Brace yourself for a deep dive into the technical realm of our next agenda. Generative models are at the heart of innovation, and we, not one but two brilliant minds guiding us through this journey. Please join me in welcoming machine learning engineers Abdul Hafiz, Fahad and Mughis Zawan.
Let me start with an introduction. I'm Mughis Zawan. I'm a machine learning engineer at Red Buffer. I have around 2.5 plus years of industry experience and currently pursuing masters in data science. I've worked with quite a few technologies including NLP, CV, generative AI and recommendation systems.
Assalamu alaikum everyone. My name is Abdul Hafiz Fahad and I'm currently working as a machine learning engineer at Red Buffer. For the past 3 years, I've been working in the domain of natural language processing, computer vision, and a bit of generative AI as well. So we'll be delivering a presentation on a topic of generative AI, which has two branches separate out, which are LLMs and generative models used for image generation.
Let's start with a little bit about LLMs, or in full form, the large language models. So the content that we'll be covering linked to LLMs are as follows. We'll begin with a little introduction and then how they perform, how they operate, what their applications are, and what are some of the latest and most popular LLMs. Then we'll also look at some interesting facts about GPT-4 and some of the challenges and the future scope of LLMs. So what are LLMs? LLMs, or large language models, are a form of generative AI that leverage deep learning techniques to process and generate text. LLMs are mostly characterized by two things. One, they have a large amount of parameters, and two, they are trained on a really large and massive data set. So the training involves a combination of unsupervised learning from unstructured data, also along with self-supervised learning, and using some data labeling aids. They can also be fine-tuned on more specific data sets. So the main concept behind LLMs was the transformer model. It was introduced in 2017, and how did it help? It brought along with it a self-attention mechanism. This allows the model to weigh and interpret the relevance of different parts of input data, thereby enabling a better understanding of each token that is in our input text. So one distinct feature of LLMs is the vast number of parameters, often exceeding trillions. What are the training and operation phases of an LLM? So we'll be talking more specifically about GPT. The process starts with tokenization. So in case of OpenAI, they use a tick token tokenizer to tokenize their text into smaller chunks. So when we give an input sentence, it's going to break it apart into a few words or even parts of a word or characters, which become the tokens for our model. Then these tokens are then sent into embeddings that capture the semantic meaning of these tokens. So when we talk about semantic meanings, we usually use the terms in NLP that a word is known by the company it keeps. The input then passes through multiple layers of our transformers, and each layer consists of the self-attention mechanism described earlier and the feed-forward neural networks. This allows the model to build an increasingly complex representation of the input data. And then in our output, we are going to generate probabilities of tokens. So when you're writing a sentence, all the GPT model does is it tries to understand what is the best probability for the next coming word. What are some of the key aspects of these GPT or LLM models? So they have generative capabilities. Before, the models that we were using like BERT or others, they used to try to understand text. But these GPT models are only trying to generate text based on what is the best probability for the upcoming word. And because of this architecture, they can be used in a vast range of fields and tasks. Let's look at a few applications of these LLMs. So they can be used for content creation, for writing articles, blogs, and stories. They can be used for language translation, as these GPT models are really good at translating every language into a certain medium language and then translating it into another language. They can also be used in education and research purposes to understand research papers better and summarize them. And they can be used for programming and code generation, which I'm sure most of you have used it for. Search engines can also be optimized using these LLMs, and Google is currently doing it with their BART model and also with BERT and other models like that. We have business analysis. So we know that mostly businesses have huge amounts of data, and to understand them, to analyze them, we can use these LLMs. They can be used in legal sector to understand legal papers and documents better, and they can be used in personal assistance. They can also be used for sentiment analysis and classification purposes, and in entertainment purposes for writing novels, movies, and game storylines. Let's look at a few popular LLMs that are currently being used and some of Google's innovations in these. So in the beginning, we have OpenAI's GPT series that we have all heard about. We have the GPT-1, 2, 3, and the most recent one is GPT-4. So they can generate coherent and contextually relevant text passages. And then we have, from Google's side, we have BERT, T5, and the recent one, BARD. BERT is a bidirectional encoder representation, also based on transformers. And T5 is a text-to-text transfer transformer, used in a variety of tasks for summarization, for question answering, and for classification tasks. BARD came out recently from Google. It's a conversational AI service that is powered by Google's Lambda. Lambda is a language model for dialogue applications. Google released BERT a while back, which is being used in industry a lot. And then they came out with MUM, which is 1,000 times more powerful than BERT. They have other new technologies, including Lambda, PaLM, and Imagen that they are working on. From Facebook's side, we have BART and Roberta. So BART is a bidirectional and autoregressive transformer, and Roberta is a more optimized and a better version of the BERT model. So the key thing here with LLMs is their parameter size. If we look at BERT, it only started with 345 million parameters. But as we move along, we go to GPT-2, it was 2 billion parameters, and then GPT-3, 175 billion parameters. Then there's a huge jump that we can see with GPT-4 models, which is near to 1 trillion parameters. This graph shows really well what the sizes of some of these models are. So we can see GPT-4 at the top right corner. And we also have WuDao 2.0 that was released by a Chinese company, and it's actually bigger than GPT-4. GPT-4 came out in 2023, whereas this WuDao 2.0 came out in 2021. GPT-4 is around 1 trillion parameters, whereas that one is around 1.75 trillion parameters. This graph is a really good representation of how large these language models can be. Let's look at some interesting facts about GPT-4, to be more specific. So through some unconfirmed sources, it has been told that GPT-4 was trained using 25,000 NVIDIA A100 GPUs for a duration of around 90 to 100 days constantly. The electricity consumption for training GPT-4 is equal to how much Islamabad would use in 60 days. Training of GPT-4 has been incurred to cost between $63 million for OpenAI. And according to some claims, It takes around $700,000 for OpenAI to run these GPT models for a single day, which is equivalent to around $21 million per month. And GPT-4 was trained on around, the data set was around 13 trillion tokens. So what are some of the challenges and the future scope of these LLMs? What are some of the problems that they're facing currently? There's a problem of hallucination in LLMs where they're going to generate text from themselves and it's going to sound so realistic that you won't know until you compare it with some other sources. That is called hallucination, and that is a major problem in LLMs as of right now. Then we also have bias concerns, where our training data set is going to incur some sort of biases in the model. We have the computational and environmental cost, as I just discussed, that the current electricity cost would be around 2 months of what Islamabad would use. And in model interpretability and explainability. So as of right now, LLMs are more of like a black box. You can't really explain them the deeper understandings. So to understand them better, the users are going to be more comfortable using them. And then we have data privacy and security. When you're using an LLM, you're providing your personal data, and along with that, there is a lot of training data. Now, I would like to call Fahad to talk about diffusion models.
So what Mughis discussed was just one perspective of what we can do with generative AI or generative AI models. The next perspective that we are going to talk about in this presentation is regarding image generation models that are very trendy these days in the AI industry. So these are the contents that we will be discussing in our presentation. So starting with the diffusion models are the generative models that can generate new data based on what input has been sent to the model. So for example, a diffusion model can be trained on human faces. It can learn different patterns. It can learn different features from the images, and it can generate those images or after it can generate images after inference so that they are more related into the complex data distributions in the diffusion models. So the basic concept behind diffusion models is that basically you are converting a simple data distribution into a more complex data distribution. So by simple data distribution, we mean that it might be a Gaussian distribution. Once the model tries, so this is a process of transformation, and once the model tries to learn the transformation process, it can gradually diffuse the images. It can gradually diffuse the noise into the images, and then we can use the process of reverse diffusion to generate our images of our subject. So this is a diagram which tells you about the underlying concept in the diffusion models. So in the first slide, you can see that there is a data which is your input data, and you then you add the noise into it, and this is the process of forward diffusion, and we get an output which is a very noisy image. So what happens in the reverse diffusion is that you need to denoise that image in which image that a noise was added in the first slide. So when you are denoising the image, you will get an image in which will be more similar towards what you are trying to achieve from the diffusion models. So that is mainly the concept behind diffusion models. So there are multiple types of diffusion models, but just to let you know, there are multiple types, but we are going to discuss about the DDPMs, which is the denoising diffusion probabilistic models. These are the models which transforms from the noisy images to the clean data sample. So you might have seen like GANs, which are the neural networks which can convert a very noisy image to a very clean image, or a very very, you can say, high resolution images. So DDPMs are for that. So score-based generative models are the ones that can generate the data samples that resembles the training data by utilizing the score function. So talking about the diffusion models in the broader perspective, so the workflow is like we have this data pre-processing. So the data pre-processing is incorporated into our systems for to ensure the proper scaling and centering of the images or your input data set, and standardization is applied to convert the data into a distribution. So if you talk about the models and the models perspective, so you are trying to achieve the mean with the 0 and the variance with the value of 1. So the next step in the diffusion models is the forward diffusion. So this was also discussed earlier as well, but just to give you an overview of forward diffusion, forward diffusion is the process in which so let's take an example of one image. So if you pick an image from your data set, so you gradually add noise to it, and then you have a really noisy image at the output of this forward diffusion. So a Gaussian noise is added, and the output is really just a noisy image. And the next step is, So this is the image of the forward diffusion, explaining that there is an image which was in your data set without any noise, and once it goes through the process of forward diffusion, it will be an image in the output which is really a noisy image. So in the forward diffusion, you transformed the simple data into a more complex data distribution, but in the reverse diffusion, you're trying to reverse that process. So by complex data distributions, you will be coming back towards a simple data distribution, and you will achieve an image which is without any noise. So, these are the steps through which we can generate an image which is without any noise, and these are all happening through the inverse transformations. As you can see in this image, so the first step is of reverse diffusion, and at each point the model tries to predict what is the noise in the image. So then it subtracts the noise from the image, and then you have the resultant image that is what you are trying to achieve through the image generation models. So if we talk about the birth of diffusion models, this was introduced, every concept in machine learning or artificial intelligence has a backstory of mathematical concepts behind it. So if we talk about the diffusion models, late in the 1980s to 2000s, there was a stochastic differential equation which was introduced. But at that time, there was no generative AI incorporated. So in the 2010 to 2014, there was the development of variational autoencoders, which is a major component in the diffusion models and also the GANs. And the next era was the 2015 to 2019, when the researchers got to know about what can variational autoencoders do, or what can the GANs do. They can be used for image generation. So in the era of 2015 to 2019, the researchers began to explore more about the diffusion models and what we can achieve from them as well. And 2020, and after 2020, there were many refinements in this domain specifically, and there were many breakthroughs. As you may know, all of the diffusion models currently in AI industry are working really good, and they're generating many results that are that can be used in many type of purposes. So if we talk about the revolutionary models in image generation, or if we talk about the top generation models, image generation models, so the first name comes as the stable diffusion. The second is the Imagine, which was introduced by Google. The third one is DAL-E2, and the fourth one is Glide, and there are tons of other as well, like Midjourney, etc. So all of these diffusion models, they have really a difference in the key components of those architectures, but all of the diffusion models works as we have discussed earlier in this presentation. So, if we talk about the revolutionary models in image generation, we are going to discuss a bit about stable diffusion. So as I've told you that every diffusion models, they are only the difference between the key components of them, but we can discuss the stable diffusion model in order to get a more comprehensive understanding of what diffusion models can do. So, so the stable diffusion model is specifically based on the latent diffusion model. So as the diffusion models might be different, so the stable diffusion model might be different from other diffusion models. The reason is that we are using the latent space representation in the stable diffusion. So, why not just the diffusion model? So why not just the diffusion model? The reason is behind when you do the inference on these type of models, the denoising is a very slow process. So, and it consumes a lot of memory when generating high resolution images. So, when we talk about the latent diffusion model, so in latent diffusion models, we introduce the concept of lower dimensional latent representation. So we are not talking about the actual pixel space now, we are talking about the lower latent representation. So what happens with the lower latent representation? So so the data you're trying to convert into a more complex data distribution, your data will be squeezed into a lower type of representation, enhancing the memory, enhancing the computational power. So that is why a latent diffusion model is used in stable diffusion. So if we talk about the main components of stable diffusion, there are three mainly. So the first one is the variational autoencoder, which consists of an encoder and a decoder. So the process of encoder is to convert an image into a latent representation, and the decoder converts it back to the latent representation. So the second component is UNet. So the main purpose of the UNet is to understand what type of noise has been added into an image. So, so as you can see, a noisy latent acts as an input to the UNet. So UNet is a neural network in which a noisy latent is going as an input, and the output is going to be the noise that you need to subtract from the images. So, and the third and the last main component of stable diffusion is a text encoder. The text encoder is usually a simple transformer-based encoder that maps a sequence of input text to a sequence of latent text embeddings. So stable diffusion does not train its own text encoder. It uses the CLIPS text encoder in order to achieve the process of diffusion. So if we talk about the comparison between revolutionary models in image generation, so this is stable diffusion, this is DALI 2, this is Imagine, and there is this Glide. So if you take a look at this table, the main difference is just in the key techniques and the output control. So if you talk about the stable diffusion and the Imagine, which was introduced by Google, so stable diffusion is the key techniques of stable diffusion is the noise addition and iterative refinement, whereas Imagine consists of a T5 text encoder and diffusion upscaling. So if we talk about the output control, the stable diffusion is just to tune the image quality, and Imagine has a very good control over the image realism. So, being from Red Buffer, we have been working on multiple generative AI products. So the first product which we launched in the year of 2023, which was known as the AI Photos. This was an image generation model. So this was an image generation system which was developed on Dream Booth, and Dream Booth, we'll talk about the Dream Booth later. So, so AI Photos is a cutting-edge avatar creation tool. It generates over 150 of your avatars. We have 3 classes in it. You can input an image of male, female, or couples. You can also generate high-quality videos, ensuring 4K outputs using the deform stable diffusion. That is another model for the video generation. So the pipeline of so if we are talking about how to develop the products or how to develop the systems of generative AI or specifically about the image generation model, so this was the pipeline that we used for developing the AI photos. So the first step was to fetch the uploaded images. The second step was to apply the face detector on those images in order to ensure the better quality, in order to ensure the better outputs, more towards realism. And the third step was just to train the model, and the next step was to preserve those weights, and the last step was to create the avatars using weights and prompts. So the prompt engineering is, you can say, the main component of this whole system. So the prompt engineering took most of our time because the outputs we were trying to achieve totally depends upon what your prompt is. So the last step is also the upscale image resolution, but this is a different type of package that you need to opt. So these were the sample of AI photos. We tried to achieve more towards realism. We tried to achieve better outputs from this model. So the major key takeaways is that there is this really great innovation in AI-driven image creation, but the major part that I would like to discuss is that ethical and responsible AI use. So this could be so these generative models or image generation models could be might be misleading for you as well. So we need to handle them with care, and yeah, that's pretty much about it.